So what we have here is the range of new data loggers, the NRL range from Unidata. It comes in a number of different form factors depending on what features you need. From the smallest and obviously cheapest version, which has a limited number of inputs and outputs, all the way up to the 16 channel one, which has a wide range of inputs and outputs for all sorts of different features. One of the most common ones we'll use will be the 4 channel, and we've got this mounted on one of our standard panels. Mounting it on a standard panel brings out all these inputs and outputs into a standard format, which makes it easy to connect anything to, and we've also got power distribution available for all your sensors. So this basic version is the 3004. It's got cellular communications in here, and we have space for a SIM card, goes in there. We've got analog inputs, counter inputs, SDI12, we've got Modbus, and we can also switch an output on and off. So this is pretty much an equivalent to the old Neon NMM data logger. So this is pretty much a straight replacement for the old NMM data loggers, except it has the advanced memory features and enhanced capabilities of the NRL data logger range. Next up, we've got the 4 channel metal box. This has much the same features as the old one, but because all of the channels are brought out to here, it makes wiring much easier. Again, we've got cellular communications, we've got analogs, counters, SDI12, Modbus, and we've got 2 outputs available here for switching. The 8 channel NRL has got, again, it's got more analog outputs. We've got 8 on this one. We've got more counters, there's 8 counters. We've got controllable power supplies, switchable outputs, switchable relays. On these upper models, we've got 2 independent SDI12 buses through here, which means that you can have one side as the logger as a sensor and the other side talking to sensors, or you could have different sensors on different buses if you want to keep them independent. We've also got 2 Modbus ports here. The Modbus ports are for communicating with more industrial or SCADA applications. The 8 channel is also the first one that has the Ethernet port. The Ethernet port can be used to communicate with Neon over a satellite communication or over any standard Ethernet connection, so it could be broadband or just whatever's on site. And it also features 2 SIM cards, so you can have fallback from one SIM to another, so you can have redundant communications. The 16 channel, obviously we've got 16 analog inputs and 16 counter inputs, as well as, we've got 8 counter inputs, as well as 2 SDI12, 2 Modbus, a wide suite of digital inputs and outputs. And again, this upper model has an Ethernet port for communications with anything with internet connection. So on the LCD, you can view current readings in the scheme and you can configure communications parameters. It makes it easy if in the field you can check what the readings are without having to bring out a laptop. Okay, so all NRLs have got some common features. They all feature an SD card slot. Now there's this one here, which is a little vertical mount one. We've got one here, or here, or here. And for most field operations, the most common thing that you'll be doing is updating firmware. So that can be done all through the SD card. So one of the first things to cover will be communications with the data logger on site. All NRLs have a USB connection. The large metal box ones use the large USB-A type connector. Whereas the small metal box ones, due to the size constraint, uses the small micro USB, which is the same as you'd have on many of the Android phones and a lot of accessories.
Okay, so we basically need 2 new cables, but no key span.
No key span, no. So the USB connection has the serial interface already built into it. So when you plug it into your laptop should automatically detect a new connection and it will be available for use. With Windows 10, the drivers should be loaded automatically. but we can't guarantee that. Right, so we've plugged the NRL into the laptop, and now we're going to run Starlog version 4. And the first thing we can do is we can look at the connection options. And if we drop down that list, we can see we've got a new option here called USB serial port COM11. Now note that Starlog only looks for new serial ports when you first start up Starlog. So if you plug in the logger after you've already got Starlog started, it won't see that COM port. But what you can do is you can click on this refresh button and it will reload the ports, and then you should be able to see it in the list. Okay, so once we've selected our device, the communications is exactly the same as you would for an NMM or other Unidata logger. So you might want to do test mode to see what is going on the data logger. And we can see this data logger is currently running. It's running the program. These are the channels that we're getting back from the sensor. And here, of course, we've got some data.
So no different.
So it's no different to previous versions. Right. At this point, we should note that the NRLs can operate in two modes. It can operate it in a standalone mode, or it can operate it as a telemetry mode. Now, in a standalone mode, you program the data logger on site, and you have to unload the data on site. In telemetry mode, the logger will connect to Neon. When you initialize the logger, it will get the program off Neon and then push the data back to Neon. So in telemetry mode, it operates exactly the same as the old NMM data loggers. But in standalone mode, you can reprogram it. You don't need to have cellular communications, but you have to download it locally. You can't telemetry that information later. We should note that all NRLs have got non-volatile memory. So we can actually remove the power from the sensor, from the loggers, and then connect it up again later, and it will restart from where it left off. Note, of course, that this may result in gaps in the data, but the logger can handle this. So this logger is currently in standalone mode. We can tell that because we've got a program icon here and an unload icon here. So we've got the program option here, and we've got the unload option here. So what we can do from this site as a standalone mode is we can unload data. So we can click unload, and we have the usual options. You can do a full unload, which gets everything on the data logger. Note that an 8 megabyte data logger, it could take several hours to download all of that data. However, for normal operation, you're not going to use 8 megabytes of memory, and so it'll be much quicker. You can also do a partial unload, which will unload between two set dates, or you can do an incremental unload, which is the amount of gets the latest data since the last unload on this laptop.
Right, same as before.
Same as before. So we could perform a full unload.
What?
You could say for a quarterly unload of data that it might take you 5, 10, 15 minutes depending on what you're logging. So remember to take that into account. So after an unload, it gives you the option if you want to save the current unload pointer. What this means is if you want to come back at a later date and get the latest data only, then it will remember what that point was. So I'll select yes, and then from now on I can unload whatever the latest data is.
But only on that laptop?
Only on this laptop.
Yep.
Okay, so now we've got our data file, we can have a look at it. Double click. Not very good looking data, is it? This is of course rubbish data, but you can see that you can select through all the different channels.
So much the same.
So this is exactly the same as any other Unidata data logger. Now, as a standalone data logger, we can also reprogram it. This option will only be available if the scheme that you're using is configured for standalone mode. So we've selected the scheme we want. We can tell that it's in standalone mode because we've got these options for program and unload. So if I click on program, it'll warn you that it's going to erase all data on the data logger. So ensure that you've downloaded any data you need before clicking on OK. So we'll go OK. We'll connect to the data logger and it will send a new data logger program. Okay, so once complete, it's a good idea to go into test mode just to make sure that everything is going as you'd expect. And we can see that the logger here has started up. It says that it's logging. The date and time on the logger is correct. And you can see that the channels here have been populated. We'll note that there's no readings yet. This is an SDO12 sensor and it only reads occasionally. So in general, we'd wait for new readings to come through before we'd leave. Okay, so we can see that the logger has now taken a reading. We've got values populating these channels. And then the latest log, we've got the latest values here logged. So this is all correct. Okay, so now what we're going to do is we're going to configure this logger for telemetry mode. Now you'll see in telemetry mode that we've got different icons up here. We no longer have an unload button. This is because the unloading of data is handled by Neon. And instead of a program button, we've got the configure initialize. If we click on the configure initialize, you'll see this is the same window as you get for an NMM. You'll note that you can also expand out this window to the right, and this will give you information about what's going on while it talks to the data logger. So the first step we'd do is we'd go retrieve settings. Okay, so now we've downloaded the settings from the logger. We'd need to make sure that the settings match what we're going to be communicating with. So for the first step, we need to know the server IP address. Ours would generally be this address. It depends on your cellular provider. For NIWA sites, we've got a special Vodafone address. Otherwise, we've got the external address, which we'd use for Spark or for satellite communications. If you use a different Neon provider, then the address will be different again. So I'm going to set this one up for Vodafone. We have to enter the XRT ID. This is a number that is uniquely allocated by Neon to identify it in the database. So I can quickly go into Neon. I can see the NRT ID here is 5095. So I can enter that here, 5095.
That's the same as before then, Steve.
Yep. This is the same as before. And again, the APN, this will be provided by your telco. For NIWA Vodafone, we'd use niwa.co.nz. For telecom, it's internet. And if you've got your own provider, it may be something different. So now all these settings are correct. What we can do is we can go send configuration. And Starlog will push those latest values back into the data logger. Has to match the
So this is something Kevin would normally set up for us too.
Yeah.
Neon.
Okay, so now we're sure that we've got the right settings in the data logger. We can try initialize through this button here. Initialize will tell the data logger to connect to the internet, and it will then talk to Neon and download the program and then start logging. As it progresses, we'll see some useful information scroll through on the right hand side. The first thing that you'll notice is that it shows an RSSI value. This RSSI is the signal strength. Of good value will generally be above about 10 and it goes up to 30. Anything below 10, you're going to get possibly intermittent or poor communications. The logger may fail to initialize properly, or data may be intermittent in its retrieval.
So in that case, we don't, what you're saying is we don't have the option to program it locally and then it carry on.
There you go.
Okay, that's interesting. Mm-hmm.
So once complete, Starlog will tell you that the logger has been initialized. If it fails, it will give you some information on the reason why, but you can also scroll up on this right hand side, and some of this information may be of use to a NIWA technician. It can tell you information about why it's connecting to what networks and what problems it's receiving.
What would be an example of a common problem?
A common problem that you might see is it'll be stuck at this +C reg. Now this is where it's trying to register on the cellular network, and the 1,2 means that it's currently searching. If you see it going 80 plus C-reg plus C-reg plus C-reg over and over again, it can't see the network. This could be either due to poor communications or it could be due to a SIM card error. Poor communications could be improved using a different aerial or else choosing a different network. Okay. So now the logger has initialized, again we can go in test mode just to make sure that it's doing what it's supposed to be doing. Okay, so we can see that the logger has initialized, we can see that the time is correct, we can see that it's taking data logs, and these channels here have not yet been populated because this particular program only reads the sensor once a minute. Okay. So, if you get into a situation where you've gone on site and you've tried to reinitialize the logger and it doesn't work, what you can do is you can put it into standalone mode. The advantage of that is that you'll continue to get data. The disadvantage is that you will have to come back to get the data off the logger. But in this situation, it could be that you've gone to get a different SIM card or a better aerial. So to change the mode of the data logger, we go into the scheme editor. And from the scheme editor, we go into the instruments window. And from the instruments window, we find the NRL instrument and double click. So from within this instrument, we can configure some of the features of the NRL data logger itself. You can see up the top, it's currently set to neon mode. What we'll do is we'll change it to standalone mode. Click OK, and then save. Now when you close the scheme editor, if we reselect that site, we'll see that the icons have now changed from the configure initialize to the program and unload button. And so from here you can reprogram it. Now note that programming it resets the XRT ID in the logger to 0. So that means that when you want to switch back to telemetry mode, you'll need to change the scheme and then you will need to go into the configure initialize window and change the XRT ID to what it should be.
So that's all the same for every model there, no difference there.
Yep, all the same. So occasionally you might need to upgrade the firmware in the data logger. So this could be due to fixes or changes in the data logger, or it could be due to new features being added. Now you can upgrade the firmware remotely over the cellular connection, but the most reliable way is to use an SD card on site. So what we have here is a micro SD card. It's formatted to FAT system. Now on this is a folder called Unidata, and in that folder is the firmware files. Now these will generally be supplied to you by NIWA as required. The card goes into the SD card slots. All NRL data loggers have the SD card slot somewhere. And then to communicate with it, we go into the Diagnostics bar here. We'll click on Comms window, check the COM port is correct, and go connect. And the first thing you'll see is some asterisks coming back from the data logger to say that I'm awake in here, and we can click on NRT menu. This takes us through to the menu mode. To upgrade the firmware, we need to enter the PIN number. So we press P for PIN, E for enter, then 1, 2, 3, 4. That's the default PIN number, and it may be changed depending on who is your supplier. Once you've entered the PIN number correctly, we'll see we've got two options now, and we can go escape to go back up the menu. The menu we're looking for is MMC SD, so we press M for that. And now we can see we've got new options here. Okay, so now we'll select F to update the firmware. So the logger will search the memory card for the latest version on the card. And note that if the version on the logger is newer than the version on the card, the logger will still load that older version. So you have to make sure that you've got the latest version on the card to ensure that you actually upgraded. Is that enough for firmware? So while we've got the SD card still in the logger, we can go over a couple of the other options. So not only can you update the firmware, if you have a problem with the data logger, there is also a dump memory feature. So you see one of the options here is D for dump. We can go D. And what that does is it dumps the current data logger memory to the SD card. Now the memory will be stored in a binary format which will be hard to read, and so you'd return that to NIWA to see if we could extract any data from it. So you'll notice that there's also the dump utility is still retained in Starlog. You could use that as well, but for 8 megabytes it'll take several hours to download all of that data. So using the dump memory feature within the NRL will dump all that information to the SD card in a matter of minutes. So from within this menu mode, we've also got a few more useful diagnostics. So for a start, we can look at diags, D for diags, and we can read the inputs and the outputs. One of particular interest is the comms. So I'll go C for comms, and quite often we'll need to look at what's going on the SDI12 bus. We have many sensors that use SDI12 for communications, and occasionally we need to actually see what a problem is. So if I select S for SDI12, it's going to ask me for 0 or 1. This is for the SDI bus number. For the smaller data loggers, there's only one option, which is 0. For the larger data loggers, 0 is for SDI bus 0 and 1 is for SDI bus 1. So in this case, I'm going to select 0. Now it'll tell you that it's in SDI12 mode, and if you just leave it like this, what will happen is you will see any communications going on between the sensor and the logger. So this is very useful for diagnosing any problems. So you can see the communications coming back from the data logger to the sensor. And that information, we can work out if the sensor is sending sensible data and if the logger is interpreting it correctly or not. We can also send commands to the logger and to the sensor. So if I sent, for example, a 0i command, these are standard SDI12 commands, we can see that the sensor is returned with its identification string, which should match what the sensor attached is. To exit, we just press escape.
Yep.
So one thing you need to do with the NRLs is you can set the priority of the communications. The NRLs come with a number of different communications options, such as cellular, LoRa, satellite or Ethernet, and you can choose which option gets a priority for the connection. So to set those, you've got the data logger connected, and then we come down here to Diagnostics, Comms window, check that we've got the right COM port selected, and click on Connect. You'll see the asterisk prompt from the logger to say that it's active, and we can click on NRT menu, which will start Diagnostics mode. So from Diagnostics mode, what you do is you press the first letter of each of the options. So for communications, I'm going to press C for comms. And then we can see P for priority. This lists the priorities that we've got. We've got an option for SIM card number 1, SIM card number 2, satellite, Ethernet or LoRa. The one with the highest number will get executed first, followed by any that are a lower number. If the number is 0, then it'll be ignored. So we can see at the moment, for this site, it is currently set to Ethernet as the highest priority, followed by SIM card 1. In this situation, when it tries to connect to Neon, it will first of all, it will check for an internet connection through the Ethernet. If that fails, it'll try through SIM 1. If that fails, then it will shut down and try again later. If you want to change the priority, then you have to enter the first letter of each of these options in the menu mode. So for example, if I want to disable Ethernet and I just want to talk on cellular, what I can do is I can go E for Ethernet, 0 to disable it. And now in the list we can see we've got SIM1 is set to the first priority, and SIM2, satellite, Ethernet and LoRa are all set to be disabled. Say for example I want to connect over Ethernet, which includes BGAN terminals. Then I'd go E for Ethernet, I can go 2, and we'll see now Ethernet or the BGAN will be executed first. If that fails, it'll fall back to the SIM card on SIM card 1. Say I want priority to the SIM card and satellite as backup, then I can go 1 for SIM 1. I can set that to a higher number, so I'll say 2, And then we'll go to E for Ethernet, which includes BGAN. I can set that to 1 and press enter. And we can see now that SIM card 1 has got the highest priority. That will be tried first. If that fails, it'll fall back to Ethernet or BGAN. Is that about it?
Yep.
Yeah, that's pretty much it.
Yep.